I'm Chris Dillon of GameKeto. Do you have a web browser and a text editor? Because if you do, then you can start programming video games immediately. So the game we're going to make today is a classic. Real simple stuff. Because of course the purpose isn't to make this specific game. Got all the features though that are going to be the underpinnings of every game you're ever going to make again. You'll learn to handle motion and collisions and bouncing. A little bit of simple artificial intelligence. That paddle on the right side moves entirely on its own. How to handle input, like moving the mouse to control this paddle. You're going to see all that today. And the technology we're going to use for that is HTML5 JavaScript. And it runs in a web browser. So I'm showing it to you right here in Chrome, but it would work just as easily if you prefer in Firefox or in Internet Explorer. If you're on a Mac, you can use Safari. If you're on a Linux box, most of those web browsers will probably support HTML5 Canvas by now as well. And even though I'm saying HTML5 Canvas, really our game programming is going to be happening largely in JavaScript. HTML is short for Hypertext Markup Language, and HTML is how people format standard web pages with headers and paragraph bodies and bold and italics text. It's like for designing a newspaper or a magazine layout, but for the web. And that is what all browsers across all computers are interpreting, including even smartphones, all use HTML to display their web pages. Now the problem is that for dynamic content like a video game, where you need motion constantly happening, you need complex logic going on for your gameplay, you need real-time mouse input, for that to work, you need something a little more complex than just laying out text on a page or images on a page. And so what they've added for HTML5 is something called a canvas element. And this black rectangle within which the game is taking place is actually a canvas element on a web page, a pretty plain, simple, otherwise empty web page, that then we use JavaScript within the HTML to bring to life. So all the actual logic and motion is being done in JavaScript. So even though this approach is called HTML5, really 99% of the code we're going to write today isn't actually HTML at all. It's going to be JavaScript embedded into our HTML. I'm just going to right click on my desktop. Let me zoom out a little bit. So you see here, it's just a normal Windows view. Nothing fancy. This black area is just my desktop. I'm going to right click and say new folder. Just a place to put this stuff. Like I said, you can do this on Mac, you can do this on Linux. Part of what's great about HTML5 JavaScript is the games you write here are instantly cross-platform. You can just run on other computers trivially. Okay, so we got our browser, we got our folder on desktop, and inside this new empty folder, I'm going to create a new text file. Right-click, new. Now, I want to create a new text document. And if you're on Mac, of course, you probably do this by opening up a plain text editor, something like Text Edit, make sure it's set to plain text, and just save the file. But on a PC, you can right-click, go to New Text Document. We don't want a Microsoft Office Word file, we don't want an open document, we don't want a rich text document. Those will have complex, messy characters for formatting and layout information. We just want a file that's just letters in it, which is what a text document is. Now when I create this, notice how it says .txt at the end. Let me zoom in a little bit in case you can't see that. It's showing the .txt at the end because my file extensions are shown. And by default, most modern operating systems hide that information from you. So if you're not seeing the TXT, you're going to want to turn those on if you're going to be a game programmer. Now the way to do that differs by operating system and version. So type in your operating system version to web search. Just search for show file extensions after it. And you'll see a number of simple 3-4 step tutorials, 1-minute tutorial videos on how to make this change. It only takes a minute to do and undo. What it's going to do is expose to you the type of your files. And what I mean by default it's hidden is that a casual computer user doesn't necessarily care whether an image's format is .png, .gif, or GIF, or .jpg. And they don't care if a sound file is a WAV, an OGG, or an MP3. They just need to know if it's an image or a sound. As a programmer, you have to see that file extension, because when you reference it from code, you need to reference the full file name, including that extension. Additionally, there's a few situations, as you'll see very soon, where we're going to actually rename the file extension on a file to change how it gets interpreted by a browser or other things that we're working on. So in general, it's going to help to show those extensions. And if you share the computer with somebody else who doesn't want to see them, it only takes a minute to flip them back off when you're done. I'm going to rename this file, which you can press F2 on Windows or right-click and go to rename on a Mac. Click on it and press enter. I'm going to call it game.txt at first. I'm going to open it up in Notepad, which is my default text editor when I double-click. Any plain text editor will do. If you have something like fancy like Sublime Text, which you see down here, that'll also be great, but Notepad gets the job done. And we can type any text that we want in here. Chris Dillon was here. Okay, simple stuff. I press Control S, or you can go to File Save to save it. And now I can view this text file in my web browser by just dragging it from my file system onto the viewable area of my page, and I can see Chris Dillon was here. Now, the foundational idea of HTML has to do with tags. So I can say like this text is thick because it has an open bold tag, B is for bold, and a close bold tag, the slash is a close, and I is for italics. This text is slanted, /I, and this text is normal. I can Control S to save or go to File, Save in the menu. And this is just the real simple, real straightforward, plain HTML kind of stuff with open and close tags, where the text between here will be seen as thick and bold. Text between the I tags, open and close has the slash, will be slanted or italicized. And let's see how that looks in the browser. I can refresh it here. The first time I click this, though, I'm going to see those actual typed characters. I don't see bold and italicized text. And the reason for that is because this file's extension is .txt. The browser is looking for that end of that file to be .html to know what to do with it. So let me close my file from Notepad because I'm about to rename it. And here's what's going to help that we have the file extension shown. I can right click, go to rename. I don't want to change the word game at the left of the period. I want to change the txt on the right half of the period to .html. My operating system is going to warn me. It's like, Chris, are you sure you want to do this? Because that's going to change what programs think you're trying to do with this file. And I'm like, yeah, we're game programmers. We know what we're doing. Trust us. Yes. We have this new file. I'm going to drag it onto the browser. We haven't changed the contents of the file at all. And bam, right there, you can see plain as day, we have our bold text and we have our italics text. All right. Now we want to open that file back up again in a plain text editor. Now, if you double click on it, it might try to open it in a web browser like Internet Explorer by default, but you can usually go to Open With, select Notepad, or choose default program. Worst case workaround, if you have to open up Notepad first, then go to File, Open, you can get to it that way. We can go to File, we can go to Open, make sure that the type isn't just text documents, but all files over here, and you can then get to your file that way. But you want this edited again in a plain text document, and again, notice it has the same contents, we just changed the end to .html. And yet it's being shown different in the browser, because that extension tells the browser what we want to do with those tags. Now, HTML has some other stuff that it really wishes we would put there for it. So, like, for example, move this down up a little bit into your way. All right, so for example, formally, it kind of wants an HTML at the top and the bottom. And there's some other information it wants that actually tells it which version of HTML we're using. Make the bottom in a closed version. But we're not too worried about that here. It might throw an additional warning in Firefox because we're missing some stuff indicating that we're not using Chinese or Greek character codings or other kind of fancy stuff like that. Browsers are pretty forgiving because they're used to people writing incomplete, hacky, sloppy web page stuff. So we don't have to worry too much about that. The reason for all this, though, is that what we're going to do for our games is use the script tag. Script and script. And these open and close just like the bold tags do. The only difference being that between them, it's no longer HTML we're writing. We can't put bold and italics text in here. We can't put headers and paragraphs in here. This is for writing JavaScript code, which is going to be logic, control, flow code, which will mean functions and variables and all kinds of stuff you're going to become familiar with pretty soon through what we're doing. An example of your very first line of JavaScript, though, will be, "Hello world!" exclamation point. I'm going to go press Control S to save, or File, Save in the menus. And then let me walk you through what we're looking at here. Again, between the open script tag and the closed script tag is JavaScript only. No HTML can be in there. I've indented the code. Indenting is actually optional, but helps readability for programmers. The computer doesn't care one way or the other. But it makes it easier for me to see where our code is versus the HTML around it. Console log is a built-in script command on the JavaScript browser's interpreter that allows us to post messages to our error log. I'm going to show you where that is. That's why we're doing this. It's going to be a very important part of programming games in this way. In the parentheses, we give it what's called an argument, which is the information that we want to send to that function to do something with. And we could change what's in these quotes to be any words we want. We could say, Chris DeLeon was here. We could say, I'm now programming games. We could say, oh my God, did it work? Anything you want between these quotation marks, you can put there. And then, to close the line, we have a semicolon at the end. Now, the semicolon is technically optional. In JavaScript, it's not required. The browser will usually fill it in for you. But most modern programming languages that look a lot like JavaScript are actually requiring of it. So Java and C++ and processing and ActionScript 3, they share a lot of structural similarities to this kind of programming, but they require the semicolons at the end of every instruction. So it's a good habit to get in. You'll see a lot of JavaScript programmers encourage other programmers to use these because even though they're optional, It's just a good habit to be in. So I'm going to save that file. I'm going to refresh it in the browser, and I didn't see any change. Let's change the text at the end of it. New text added here. Okay. Control S to save it. I'm going to refresh in the browser. Remember too, if you're not seeing your file at all, make sure you've dragged it over since you've renamed it. Alright, so tennis game, drag it over. And we're seeing new text added here. So this is definitely the newest version of the file. But the difference being that we're not actually seeing that hello world statement. Where it went is the console log. And to get there in Chrome, I'm going to click on this grip in the corner, this little 3 lines thing. I'm going to go down to More Tools. And then I want to go to the one that says JavaScript console. And then right down here on the side, I will see hello world game.html:5. That 5 means that it's on line 5 of the code is where that statement comes from. And hello world is the phrase that I picked because since the 1970s, this has been the first thing that most programmers of any programming language display to the screen. So if you did this with me and you're following along, and I encourage you to if you're not, welcome to the club. You've just joined in with the rest of us game programmers. Now, this will work in any other browser as well, but how you get to that console for the JavaScript is a little bit different. So here I've opened up Firefox. I'll drag my HTML file onto it. I once again click this 3-line grip in the corner, but now I go to Developer, click on that, and now I choose something called Web Console instead of JavaScript Console. And I'm seeing there's my hello world, game.html:5, again line 5 from the game.html file. And then I'm getting this warning of the character encoding is not declared. So this will be trouble if I use characters outside the US ASCII range. This means if I have Japanese or Chinese or Greek characters on the page, it might confuse the web browser how to display it. Pretty harmless warning we can ignore. You see it's yellow for a warning, not red for an error. We'll let this slide for now. There's a way we can fix that with some additional HTML information. Not a big deal. And now over in Internet Explorer, there's a little bit of a quirk to how we're going to have to do this. I'm going to drag it onto our page. And once again, so you see it right there. Now first off, Internet Explorer is being cautious. Lots of people have taken advantage of Internet Explorer over the years and made it a way to distribute bugs or run otherwise malicious scripts. So it's warning me. It restricted it from running scripts. Do I want to allow it to run scripts? Remember, we're using all this in a script tag for JavaScript, so yes, because that's what our game is. Allow blocked content. Now, let's say how do we get to our console? Click on the gear, F12 Developer Tools, and we won't actually see it here. And the reason is because it tried to display that before we opened the console. Internet Explorer works a little bit differently than Chrome and Firefox in this regard, in that it will only display a console log if the console was already open when the code ran. So now that the console is open, I can refresh the page, clicking up here, pressing F5, and down here we'll see, same deal, hello world gets printed out in the console log, which is exactly what we wanted. Now the console log isn't just for displaying messages we want to print out to ourselves as programmers. And there's a number of reasons we might do this, by the way. We might surface information as we're programming. We can print out numbers we're trying to debug. We can print out where the code is going if we're not sure if a part of it's being activated. But it's also the place where we will see errors. So let's say I was typing this word and I made a typo. I left off that E. That's going to be a problem because it doesn't know what console without the E is. Let me save that, refresh in the browser, and now instead of seeing hello world, I see uncaught reference error console is not defined, game.html line 5. This way, no matter where you make errors in your code, if you have a typo somewhere, it'll tell you what the word is that's offending it and what line to look in which file. So if you're used to other programming languages and you're just coming to JavaScript here, this is kind of like your compiler. This is your errors or feedback. Now, if you get these, they'll come up all the time. Don't feel bad. You're not doing something wrong. You're not a bad programmer. Part of programming is just dealing with errors that crop up each time you work on your code. So whenever you see these, don't feel, like I say, don't feel bad. Don't, beat yourself over it. I've been doing this stuff for 15 years. I still see errors all the time in that console log. So we have our program console log opening and displaying the message. There it is. And in the next part of these videos, I'm going to be showing you how to put up that black canvas and start to get some action and graphics happening on it. Talk to you more in a sec. Hello and welcome back. So this is part 2 of this short video series on making a simple game using HTML5 JavaScript for first-time gameplay programmers. And what we covered last time, just a quick refresher in case you took a break, we showed some real straightforward HTML, including a script element to put JavaScript in. We created a file, we renamed its extension.html, dragged it into a browser. I'm using Chrome, but you can again use Firefox, Internet Explorer, doesn't really matter. And then we saw that in our JavaScript console, it would show us errors if we had a typo in our code, or otherwise it would show us our console logs and which lines those came from. Now, what we're going to start doing is we're going to start adding some graphics and other functionality to the program. And this is going to take a few little steps to get there, but bear with me. First off, we no longer need this text at the top, or at least we don't need all that text. Let's just put some text here. Doesn't really matter, not terribly important. Let me zoom in on what we're doing in this area. And the first thing I want to show is something called window.onload equals function. This little bit of funniness right here. The way that this works is the special thing that we can do in HTML5 JavaScript specifically that says that as soon as the window finishes loading, that's what this window onload is bit, run the function or the series of code described between these braces. Now, what all that means might sound like a bunch of Greek if you're new to programming, but the gist is that we don't want our code to actually start running for our game until all of our page, and therefore all of our code is finished loading. This allows us to be a little bit more loose and free about the order in which we define functions or blocks of code that we then want to use. So we're going to start off with it here, saying we don't want any of this code to activate until it's finished loading and then run it. Otherwise, what happened when we didn't have this qualifier around console log, when the code got to the console log, it was running. Now it's going to happen only after the page finishes loading. We're going to be adding what's called a canvas element, which is where our graphics are going to be taking place. So up here in the HTML section, not within the script, we're going to create canvas ID equals game canvas, width equals 800, height equals 600. I'm going to close it, and then I'm going to do a close tag right after it, /canvas immediately after. And all this is saying is we're going to have a block for graphics on the screen for our game, really. That's dimensions are going to be 800 pixels wide by 600 pixels tall, and that's of course a good, pretty standard size for a game. It'll still fit on small, older laptop screens, but it's not so tiny that it looks terrible on a newer monitor either. And this ID game canvas is a label that we'll be able to use within the JavaScript to display graphics onto it. Now the next thing we're going to have to do inside script is we're going to declare two different variables, var canvas and var canvas context. Canvas is going to be a handle on the information about the dimensions of our display area. Canvas context is going to be sort of its underlying graphical information that we can then draw rectangles and circles or images to. Inside of our window onload function, and we want it here because it means the page is already finished loading, we're going to fill up canvas, that variable we've set up right here, with document.get element by ID. Make sure you lowercase the d in ID. I see people make this mistake all the time. Programming is case sensitive in a lot of cases. And the argument here, let me decrease my font size. There we go. Just trying to avoid meaningless wrap where we don't need it. So inside these quotes, or single quotes, I'm going to say game canvas. And this corresponds to the label up here in the ID. This is what's going to give us a handle in our JavaScript onto the canvas element on our HTML page. And next we want a handle to our canvas context that we can draw graphics to. So we're going to say canvas.getContext 2D. And just two more lines and I'll go back and explain how each one of these things is working. Next time we're going to say canvas context.fill style equals black is a terrible typing today. Black is one of the built-in colors we can recognize. We can program our own colors later, but that's the gist. And then canvas context dot fill rect, which is short for fill rectangle, 0, 0, canvas width, canvas dot height. There we go. I'm going to Control S or File, Save here, save the page. And now when I go back to my browser, which still has this open, and if it doesn't, I can drag the file from my folder directly onto the browser. When I refresh, here's our text up here, and then here's our black canvas area with our console off to the side. So we can shrink our console, doesn't need that much room. It'll be good to have it handy to look at later if we see errors. So this black area is where we can then draw our game elements. And here's how this all works. So var is short for variable, which in code is just the way you create a container that you can then reference throughout, or you can reference elsewhere. If we had an amount of lives we wanted to keep track of, that would be a variable. If we had a position on the screen we want to keep track of, that would be a variable. Anything that we want to hang on to and remember from one frame to the next, we're going to use a variable for, or if we want to calculate values or you'll sort of understand these more from context. The first code we're going to write is always going to be a little weird because we don't have context yet for how it fits in. The more we write, the more you're going to see some simple patterns of how the stuff's getting used and what it's doing for us. And then we're creating a fill style black onto our canvas, context, the graphical sort of underpinnings. And then we're calling fill rect with 4 numbers. 0, 0 is an X and Y or horizontal vertical coordinate of the top left corner. Canvas width is getting this number, 800 pixels. Canvas height is getting that number, 600 pixels, which corresponds to the bottom right corner. Now you want to pay attention to this because in classical math classes like geometry or trigonometry or most kind of graphing, you'll typically see increase in Y value or increase in vertical position be raising it on the screen. It's actually the opposite in a lot of computer graphics and game programming. So just to show you what I mean, like here I'm going to say fill style after this, and let's say red. And now let's set a position that says 100 pixels from the left, 200 pixels from the top. Let's make a box which is 50 pixels wide and 25 pixels tall. Notice too that the way fill style works is it's referring to setting the color for the fill rect call that comes after it. So even though it's happening over 2 different lines, it's kind of setting up the graphics and then doing something with it. You'll see more of that in a moment. So I'm going to save it with Control S, or as always, you can go to File, Save, refresh it in the browser, and I now see this red rectangle, which we know from the code must be 100 pixels from the left, 200 pixels from the top. Does that make sense to us? As a corner of this looks to be half as far this way as it is from top to bottom there. And then 50 by 25. Is it about twice as wide as it is tall? It must be, right? And so let's say we want to move that over a little more. We could say 120. Save the file, refresh, you'll see it bumped over a little bit. I could say 200. Save it, refresh. And now it just jumped over a little further. And we could draw another rectangle if we wanted. Let's say we want to make one that's green. And so we remember the first 2 values are how far from the left and the top, your top left corner of your rectangle are. So let's say we'll move this one over 30 pixels to the right and 30 pixels down.
Any ideas?
This is 200 pixels from the top, 25 tall, so this should have a little gap. 225 would be the bottom of that one. And let's make this one a little 10 by 10 green square. I'm going to save it, refresh it, and there's our little green square. The important part is to be able to practice and get a sense for these coordinates. Like, okay, if I want to draw something in the middle of the screen, where would I put it? Okay, well, let's think about that for a second. If I want to put this green square in the center of the screen, let's make it a let's make it a white square so it's going to be easier to see. What's the center? Well, if the window is 800 pixels wide and 600 pixels tall, then what's half of 800? 400, right? So we'll make this position. Let's just try 400. And okay, it's the total canvas's area vertically we know is 600 because that's what we set it to here. So half of that is 300. And let's make our rectangle a little bit bigger so we can better see. Let's make it 40 by 40 so we can better see it. And when I refresh it, is that white box in the center of the canvas? Kind of. Let me show you what I mean by that. If we make this box even bigger, it'll be more obvious. Let's say I make this box 200 by 200. Refresh. Remember, what these first 2 values set is actually the top left corner of the box. With the 3rd and 4th one set are its size. So if we want the whole thing centered, then we actually want to subtract half of it on each direction. So like if it's starting in the middle and going 200 pixels over, we want to bump it 100 pixels left, or half of its width to the left, and half of its height up. 300 by 200, refresh, and now that white box is centered. It's all a little messy, it's all a little headachy at first if you're new to this stuff. Again, you'll see more as we move forward on how the ball is behaving, on how the paddle's working. But if you have any doubts at all about your positions of your shapes, play with these numbers. Try putting boxes in different positions. Try to see if you can line them up corner to corner, edge to edge. Experiment for a bit with it. You'll get a lot more comfortable with how this space is laid out. Now, the other thing to know is that the order that we draw shapes in code depends on what overlaps what. So, right now, like let's say here's our white box and here's our red box. Let's say I want to move this white box over to 225 and 210. Those are positions that I can see, will overlap the red because this is going 200 to 250. This is 225. This is going vertically 200 pixels down to 225. 210 is in the middle of those-ish. So in refresh, you'll see that the white box is overlapping the red box. That's because this white box is getting drawn later than the red box, so it's painting over it. If I switch their order, I'm using shift and up and down arrow to select line at a time in a text editor. Shift and up and down to select those arrows, up and down arrows. I'm going to cut it with Control X and paste it with Control V. And so now I'm going to draw the white box and then the red box, and we should expect that when I refresh the browser after saving my file, red overlaps the white. So draw order is very important. This is especially a big deal because if I drew this black part last, which is drawing the full size of our canvas, again, just Control X to cut, Control V to paste, saving it, I won't see those other shapes at all because it's getting covered over by this black box. We move back to the top. Notice too that in these, I can use these values like canvas width and canvas height because we know what those numbers are. So what I mean by that is when I centered it, what I could have said, instead of trying to do the math in my head of like what's 800 divided by 2, I could have said canvas height, canvas width divided by 2, and that'll do for us. It'll divide 800 by 2, and it'll give us 400. So now our rectangle red positioned horizontally, about centered, again not accounting for the box's size. So that's just how to position some graphical elements on the screen, and we're going to be moving towards is getting them to move on their own. Before we do that, we're going to move all of our draw functions over into their own block of code, because this is all getting pretty complicated. Like, we don't want all of our draw stuff happening along with the rest of our game's logic. Alrighty, welcome to part 3 of this video, in which we have some shapes on the screen we've drawn to a canvas, and what we're going to do is we're going to start wrapping up our draw function into a standalone function. And what I mean by that is we're going to take it out of the onload stuff and give it its own block that we can then call easily from somewhere else. So when it's all, say, function draw everything, you'll notice that when I type that, it looks a lot like fillrect and fill style in that I start with a lowercase word and then I have a capitalized word. It's called camel casing. It's kind of a traditional programming naming convention because you can't have spaces in names for programming. And anyway, you'll see that kind of thing all the time, but draw everything because we're defining that function, unlike window onload, which is built in. Because we're defining it, we can name this anything. We could call this, elephant season. We could call it, bird flight. Doesn't matter. Anything you want to call it. It just should be descriptive of what's going on in there. And what we're going to do with it is draw everything. So let's call it draw everything. I selected this code that does our drawing, the black, the white, and the red rectangles. I'm going to cut it with Control X. You can right click and use that functional menu too. And I'll paste it between these open and close braces for draw everything. In that section right there in the middle. And the way a function works, at least in the simplest form like this, is that it just allows us to use this as a label to call it from anywhere else in our code. So this does exactly what we did before, in that when it gets to this label, it'll run the code inside here. Top to bottom, first brace down to the closing brace. I saved it, Control S or File, Save in the menu. No change yet in the browser when I refresh. Let's say I put that down 3 different times in the text. But if I run this, it's going to look the same, right? Because it's going to draw the exact same thing every time. There's no change happening here. But I could prove it's running 3 times by using this console log. Remember how that works? I'm going to cut that with Control X, move my cursor down, zoom back in. I'll paste it around here and I'll say, instead of hello world, called draw everything. And we could spell it, we could spell it out nicely. We might maybe just want to use our actual name from the function. And now every time that this console log gets reached, we'll see it again printed out into our console log in the browser. So there we are, we got it. I'm going to save it. It should see it 3 different times. And when I refresh in the browser, I see right there called draw everything, all 3 times from line 18 of the code, because I'm calling the function by its label 3 different times. But what's going to be happening is each time that we draw things, we're going to be moving them a little bit. So as long as we keep adjusting the position of something, it's going to appear to move along the screen. It's like how any animation would be drawn on paper too. So just an example of doing that, let's say that each time we draw everything, we want to move where the ball is. Well, first of all, right now, every time we do this red thing, which that'll become our ball, is being drawn centered on the screen. How could we make it so that its position would change every time we draw it? Well, this is where we're going to see a much more normal use of var, or variable. So even though when you saw this canvas and canvas context is a little confusing because we don't have anything like it, you'll be seeing a lot of this sort of thing. I'll say var ball x. Ball x should mean the horizontal position or the x-axis coordinate of a ball. This label could be anything. Just like I said, draw everything could be, elephant season. This could just say, wings, or this could say sewers. Any word. It's just a label for legibility to us. That's a clue to us of how we're going to use the number or other value that it stores. I'm going to initialize or set this number up to be 50. And what that means is that this label now refers to 50 in the computer's memory. And instead of drawing the ball, this red rectangle, at a position canvas width divided by 2, I'll draw it at position that's stored in ball x, which we set up here to be 50. I can save this, zoom back out. When I refresh it, I'll see there's my red rectangle, which again, that'll become our ball. It's being drawn at position ball x, but it's not yet changing. Well, okay, we can change it. Inside draw everything, each time we update the screen, let's increase the value in ball x. Now, if you're new to programming, the way we're going to do this is going to look a little bit weird, so let me explain what's going on. We're going to write ball x equals ball x plus 10. Now, if you're coming to this from a math background or anything else, this looks broken. Like this expression, this equation can never be correct, right? Like it's not, you can't make something equal to itself plus 10. The important thing to know about programming is that a single equal sign has nothing to do with a balanced equation like it does in algebra in programming. In programming, what it does is it takes the value on the right side and it saves it into the label on the left side. It just copies it over, it overwrites it onto the left. So if I said here, draw everything equals 70, that would store the number 70 into this label, and then the ball would be drawn at position 70 instead of position 50. If I told it to set itself to ball x plus 70, then on the right side it's going to evaluate. It's going to see, okay, what's stored in ball x? At first, the number 50. Then it's going to add 70 to it, so 130. Is that right? 7, 8, 9, 10, 11, 12, 120. Which means it's going to have 120 on the right side, save it into that value, and then it'll start drawing it there. And the next time it comes around to draw everything, the second time it calls it, it'll add another 70 up to 190 and so on. Let's stick to smaller numbers that I can handle adding. With a 10, the first time we call draw everything, it'll draw it at 50, or so it'll get here, it'll say it was 50, it'll add 10, it'll draw it at 60 and so on. You know what, all this is kind of hard to keep track of in my head. What if the computer did it for us? Instead of saying call to draw everything, right here, let's say, in this console log, just the name ball x. And what this is going to do is each time draw everything gets called, it'll print out what the value currently stored in ball x is. So we'll be able to see in the sidebar of our browser how that number is affected. I'll refresh it, and I'll see over here it was 60, 70, 80. Because each time I call draw everything, it was adding 10 more to the initial 50. Notice too that it's doing that before it prints out. That's why we never see the 50. But that's a good place to put it because that's also why the time that number has changed is also when it's going to get used for drawing the rectangle. Now, if you watch it again, we don't actually see this rectangle move. We could even increase this number. And we'll save it. And I'll refresh. Alright, I mean, these numbers are bigger. They're now growing by 20 instead of 10, so it's ending up further. But the problem is this is all happening so fast. The computer is calling these three functions at lightning speed. A computer, a modern machine, does just billions of calculations per second. It is way, way, way too fast, these number changes, for your human eyes to follow it. It's in fact too fast for your modern monitor to even display those changes quickly enough. So it's not like your eyes aren't good enough. It's like the computer doesn't even have time to update the screen. This code is happening so fast. So So we want to slow it down in order to see those changes. And the way that we can do that, and this is a pretty important magic step in understanding how gameplay and game programming works, so follow along carefully here, this is a big deal, is we're going to set up a timer that's going to draw everything at a regular interval. Now first we're going to do it at a crude, like once a second, but we can make it faster and make smoother gameplay. And the way that that's done in JavaScript, every programming language has this kind of own way of doing it, is we're going to say set interval, I'm doing this right here in window onload, draw everything, that's the name of our function, and then 1000, this is how many milliseconds I want to wait between each time the function gets called. I'm going to delete those times where I called it myself. Okay, so now right here, what I see is window onload, it waits till remember the whole page is loaded, so that means draw everything has already been defined for the computer before any of this happens. It then sets up its canvas and canvas context, which we need for drawing our graphics. Then every 1 second after the page is loaded, it's going to call the draw everything function. Each time it does, it's going to add 20 to the value stored in ball X, which started at 50, and then it's going to display that number to the console, and it's going to redraw everything, the black rectangle, the white rectangle, and the red rectangle, but the red rectangle's position will be increased by 20 every second that we look at it. Okay, I'm going to save this file, Control S, or file save in the menu. Let's zoom back out, and when I refresh it, we have motion. And again, right there in the console over here, you can see this number is getting 20 larger every frame. And the position we're seeing for this red rectangle is the same as if we had typed in 330 or 350 or 370 or 390 for the horizontal position of our fill rect for what again will become our ball. Is that making sense? There's a lot going on here. And this doesn't just have to be a position. So even though I'm using it here to mean the horizontal position of the ball, that's why I called it ball X, I could also say, always draw it 75 pixels from the left, but let's make the width of the rectangle connected to that ball X variable. So remember, all we have here is just a number that's in memory, starts at 50, increases by 20 once a second, and I can plug the number in here to change the width of the rectangle every frame, or every second, instead of the position. Let's see how that looks. And once again, this is identical to as if I had typed in 190, 210, 230, 250, 270, and so on. Each second it's updating and drawing, the next number where ball X has been increased by 20. Well, let's do one more crazy thing, all right? We can use that same label multiple places. We can have it also increase the horizontal position. We can have it also increase the vertical position. We can have it also used as the height. Now this is a terrible programming practice. This is not something you would normally do in a program because this label means something to us as human readers, right? Ball X should mean the horizontal position or the x-axis coordinate of a ball, but here I'm using it in the positions that refer to for the fill rect, the horizontal position, the vertical position, the width of the rectangle, and the height of the rectangle. Let's just look at what it does, because what I want to show you is that the computer doesn't actually care about where these numbers are being put. It's as though I had typed in 250 or 270 or 290 to all four of those positions. This is just a label in the code for a number or a value that then we can do anything we want with. We can put it in those places even if it doesn't make legible, readable sense to us. It's printing out the number here that's exactly the same as if we typed in the number there once a second. Now before we lose too much more control of what the heck's going on, let's sort of back out some of these weird changes. Let's keep ball X in a spot that makes sense as the ball's horizontal position. Let's also just put the ball 100 pixels from the top. Let's make it 10 by 10. That's closer to the shape of a ball, I'd say. Okay, save that with Control S, refreshing the browser. And now we're back to a normal thing of seeing this red ball moving along. Probably paid attention to the fact that when I press refresh, it's blank for a second. Why is it blank for a second? Because it's not calling draw everything until the set interval has happened the first time a full second later. For that matter, that's the reason why it's acting so choppy. We could make this number smaller than 1,000 milliseconds, or 1 second. Like let's say we made it 500 milliseconds, or half of a second. If I save the program, we should see the ball move twice as quickly. It looks like about twice as quickly. I mean, computer's a better judge of that than I am. Okay, well what if we change that from 500 to 100, or 1/10 of a second? Okay, now we're getting somewhere. That looks much faster. We can make this number even smaller. We can make it 50 and just zoom off the right side of the screen, right? We can decrease this number smaller than 20, the amount that's increasing it by every time, to like 5. And what we're going to begin seeing is something closer and closer to approximating smooth motion. And again, what you're seeing over here is every 50 milliseconds, it's printing out the new value for where the ball is. And how can we mentally test this? How can we check with ourselves that it's doing what we really think it is? Okay, remember, we set up our canvas, right, here in the code to be 800 pixels wide. That means that right when the ball is approaching the right side, we should expect to see that ball X, as printed out to the console, is around or reaching the number 800. Let's see if that's true. Okay, we've got a full screen view here. Refresh. Now watch the number over here. As the ball approaches the right side, we should see this getting nearer and nearer to 800, 600, 700, and 800 right there, right as across the right side. Does it make sense now what's going on with these positions, these numbers? Hope it is, and if it's not, keep playing with it. It's going to become more and more natural as we progress. Now, unfortunately, this whole thing of sticking a 50 milliseconds in here doesn't make a lot of sense to us as humans. Like, that's just not how we think about time or game frame rates. It's going to make more sense instead is to calculate that to be something we can depend on, like games often like 30 frames per second. Since we're about to be doing a lot more updates a lot more rapidly, let's get rid of this console log for now. And let's change set interval to calculate that value. I'm going to zoom in on it so we can see the program doing old stuff. I'm going to say var frames per second equals 30. And now instead of saying 50 here, I'm going to divide 1,000 or 1 second worth of milliseconds and divide it by frames per second. Okay, so that means that if we had 1 frame per second, it would make this 1,000. If we wanted 2 frames a second, it would be 1,000 divided by 2, or 500. And so this allows us to think in terms of how many frames per second do we want, and then the calculator will compute it for us. Notice too here that I'm doing this var here, right here before I use the variable, inside of window all mode, not out here in the script, which has a little different behavior. This means that this number will be forgotten by the time that the end of this function gets reached. We don't actually need to ever call this variable label, frames per second, inside the draw everything or anywhere else in our code. We just need it for this next line to do this calculation. And it's nicer this way because now we were able to put a label on it. Instead of typing out 1,000 divided by 30 and later looking at that and trying to figure out, like, what did we mean by that? We were able to put a word on what that number means to us. So this makes some sense to us that, okay, that's going to be used to calculate our frame rate. Is that making sense? But see, this makes it a temporary local variable. Now, the reason why we couldn't do that with ball X is because we need this number in the other parts of our program, and we also need it consistently remembered by the program even after the function finishes. So if we declare a var inside of a function, it gets forgotten as soon as the function ends, when it reaches the closing brace. By defining it out here and setting it up out here instead, it'll be consistently remembered, so when we add 5 to it and save over it, it'll keep that change and store it and remember it outside of the scope or outside of the functionality of that one little function. So when it comes back and happens the next time, every 30 times per second, it'll be working on the same value. So let's see what that does. Zoom back out, save our file, refresh, and now we have a pretty smooth red ball moving along the screen. Well, let's make this white rectangle more like where our paddle should be. We want it on the left side of the screen. Maybe instead of 225 pixels, remember this is how many pixels it is from the edge. If we put it at 0, that's going to have it square up against the side. Let's check ourselves. I save it, refresh, white rectangle's up against the side. Vertical position, don't really care about. It's going to be controlled by the mouse later anyway. How wide do I want this shape? Let's say 10 pixels thick, because I want a tall, thin shape for our paddle. I'll save it and refresh. I have a taller, thinner shape. And how tall do I want it? 200 seems a little too easy to play. Maybe 100 will give me more of a rectangle size I want. It looks more like a reasonable tennis paddle for these kind of classic games, right? One of the things, though, that's going on here is that we're actually mixing together our movement code and our drawing code, which at some point down the line can come back and bite you. And the reason for that is because, like, we don't want to be drawing half of the things, then moving them, then doing calculations based on their positions for other stuff, and then drawing. We want to have everything update its positions all at once, all the paddles, all the balls, everything else. or depending on the game, all the spaceships and warriors and projectiles and magic spells. We want all that to calculate first, and then draw all at once as a coherent chunk of code what the update is and what it looks like when it surfaces it to the player. So let's split apart. Instead of just having everything and draw everything, let's move our move code into a separate function, which we will call function move everything. And I'm just going, let me zoom in for you. I'm just going to cut this with Control X and paste it into move everything. So now I've got a separate function for putting my movement code from my draw update code. And now I want to update this set interval call so it'll call not just draw everything, but both of those functions. And the way that we can do that, I'm not really using a lot of specialized JavaScript stuff here, but I want to show you the thing we can do. If we have a very small, simple function, we could define it elsewhere, just like we did draw everything. So we could say function call both, and in here I could say move everything, draw everything. Notice that these functions always have these parentheses after. We can explain later how those are useful. You'll see it when we move our shapes out. And then I can put this label call both right here instead of draw everything. If that makes sense to you and that's how you like it, that's totally fine. But think about this. Are we ever really going to go back and change this function? Do we need that to be its own separate thing floating around in our code? Like, we're always going to want to call move everything and draw everything once per frame in just like that fashion. We don't need to complicate it any. We don't need to go back and maintain this. So it doesn't really need its own function. We're never going to call this function call both label from anywhere else. So there's another way to do it in JavaScript. I'm going to show you right here. I can define it in line. I'm going to say function, open and close braces, and right here I put the same guts of that call both function, copy and pasting, or cut and pasting, get rid of call both, and what I've done here is I've defined inline right there in the code that I want to be calling move everything then draw everything. In any code we want, we could throw a console log in between these, we could call other functions, except this function doesn't have a label and can't be called from anywhere else. So if you have a really small, straightforward function, you don't have to change much. That's an option. You can do that in JavaScript. It's technically also kind of the syntax you're seeing for this window onload function, if you're curious as to how you're seeing that. It's not how we're going to define most of our other standalone functions, but it's something I want you to be familiar with in case you start seeing that kind of thing in other code you look at when you find JavaScript examples out there on the web. Next up, we're going to change that red rectangle, red square, into a ball. And then we're going to get it to bounce off the edge of the screen. So stay tuned for that. Got more of that in just a moment. I want to just a quick review and look at what it is we're building towards so you can keep a good visualization of kind of where this is headed. Our goal is to get this round ball, which we don't have any circles yet, we're going to get there, to draw this net, have some text on the screen for keeping score, as well as having the player paddle move with the mouse. We have a player paddle now drawn, but it's not moving yet. And then we also want to have this other paddle move by itself to the other side. Of course, if I miss the ball, it resets to the center, and if I block the ball, then it knocks it back. And in fact, it's not just knocking it back, it's not just reflecting, it's doing something special we'll talk about right when we get to that point. We'll continue on now. I refresh, and we have this red square that'll become our ball, going off the right side of the screen, and here's the rest of our code. As our program begins to grow, there's a way that we can separate out our JavaScript code from our HTML5 so it's not just packed into a single HTML file. And that's as we build up to bigger projects, we'll start to see more of that kind of technique. In the meantime, this amount of code, it's pretty manageable, pretty fine to kind of keep it all in one place. And I kind of like that it makes it easier just to save a snapshot of your project or to share it without having to worry about if all the files are in the right relative directories and that kind of stuff. We keep it simple while we can keep it simple, and as the program begins to grow in sophistication, we'll have reasons to do a little bit of refactoring, it's called, or cleanup of the code to make it easier to expand and grow. So we've got this ball, say a ball, we have this red square, and it moves. What we'd like to do is, right now it leaves the screen, we'd like it to bounce off the edge. Now the first thing to look at is when we do move everything, we're adding 5 to it right now every frame. Remember, this is taking the value that was in ball X, adding 5 to it, and then saving it into the value of ball X. So this gets called 30 times a second, moving it forward 5 pixels every time. And the problem, the reason why it keeps moving off the screen, is because this 5 can't ever change. It can only move to the right. But just like we have a variable, or a var, for the ball x, we can also have one for ball speed x. Let's set that to 5. I'm going to copy that. And when I scroll down here, instead of making this plus 5 every time, I'll say plus ball speed x. So remember, the way the variable works is that this container, this label, which means nothing to the computer. It doesn't care about the word ball, doesn't care about the word speed, doesn't care about the coordinate, the name x. But this label to the computer, this name, refers to a number which we set as 5. And what's great about this is that now we have a variable connected to our ball speed. We can change that variable to change the ball's speed. If we make that number less during the program, it'll slow down. If we make it increase during the program, it'll accelerate. In fact, let's show you how that would look, right? So right now, as is, if I just save this, Control S, and then I'm going to bump back out to view our game. When I refresh, it looks exactly like it did before. But what if each frame, in addition to moving the ball to the right, I increased the ball speed? Equals ball speed plus 1. So now every frame, it'll increase by 1 the speed at which it's moving to the right. So this should cause it to accelerate. Let's see if it does. Save it, refresh, vroom. Right? Catch that? There it is. I guess that way on your screen, probably. No, we don't want the ball to pick up speed, but we do want to have it change direction. And how can we make it change direction? Well, if we make this a negative number, it'll go backwards. Because adding a negative to something is the same thing as subtracting from it, right? But well, first of all, let's just try that. Okay, so instead of setting it to 5, and I erase this other line, we don't want to have it accelerate. What if instead of setting it to 5, I set it to -2? Save, refresh. You'll see it wanders left instead of going to the right. And I say wander because it's going slower when it's 2 instead of 5. When I increase the number back to 5, it'll go back to the right. But in what condition do we want that speed to change from going 5 pixels to the right to going 5 pixels to the left? Well, you remember when we looked at those variables along the side, counting up as the ball was progressing towards the right side of the screen? We can see that. And what that means is that if the ball's coordinate exceeds the width of the canvas, remember this is 800 pixels wide, we define that right here in our code. The size of the window, or the canvas rather, the black playable area is 800 pixels. So if the ball's horizontal position, ball X, exceeds that width, then let's have it flip directions. Alright, let's go inside and move everything. Let's add that logic. So if ball X is greater than, we know that number is 800, we'll show in a second, we don't have to hard code it. Then, and that's how this works, is an if statement, does a comparison, if this turns out to be true, and we could do greater than, we could do less than, we could do greater than or equal to, less than or equal to, not equal to, is exactly equal to, 2 equal signs there, works different than a single, which is assignment, but we don't have to deal with that right now. If ball X is greater than 800, so if on this update cycle the ball has now moved past the right side of the screen, let's tell the ball speed to go backwards. Now there's a few different ways we can do this, right? We could say equals -5. That will tell it that when it touches the right, change the value, saved into this label, so the next time, 30 times a second, it gets to this part of the code, it'll add -5 instead of +5, and it will work its way left. And let's just show that that works. I'm going to zoom back out, refresh. There goes the red ball that way, and it hits that wall, returns it. Now a problem with this is that when I hard code this number in here like that, what if I increase the ball's speed? Let's say we have something in our game code, as we might later, that the game speeds up as we play it. So just to experiment, what if the ball's going 15 pixels per update to the right, and it touches that other wall, it'd be quicker to test at least, goes over there real fast, and then it goes back slowly, because of course, by setting this number to -5, it's forgetting the speed it was going. What if instead, we set it to negative itself? So if it was going 15, it'll reverse at 15. If it was going 5, it'll reverse at 5. You'll see that all I did here is instead of setting this to a hard-coded number, meaning a number that is typed directly into code, I can now have it maintain its speed, no matter how fast it was or wasn't going. If I make this 10 as the ball's initial speed, zoom back out, refresh, it'll go over there at 1 speed, bop off the wall, come back at the exact same speed, which is closer to probably what we want. Now the other thing you talk about hard coding is we have this 800 here. And that's not good, because if we want to change the size of our window later, if we want to make our game 1,000 pixels wide instead of 800 or whatever else, then ideally we want to avoid typing in numbers that are already somewhere else in the code. So what we can do, I showed this a little bit earlier when we're drawing different shape positions. We can actually say canvas.width. And that works because we have this canvas variable that we set up earlier, that one right here, which we then prepared inside the window all node function by grabbing the HTML element game canvas, which we defined up here that's the label for the 800 by 600 canvas we're drawing. Speaking of 800 by 600, that is the width and the height variables that we can get our information from because we have this handle to it. So that when I say canvas.width here in this comparison, the computer knows that what I'm really getting at is I want the width parameter of that canvas element that we grabbed earlier, which is 800. And what's nice about this is that if I later change that window, it will automatically be reflected in it. And moreover, it's just easier to read this code, right? When I look at that statement, I can understand that, okay, if my ball goes past the edge of the screen, past the whole width distance from the left side, then flip its direction. That makes more sense than 800 and thinking like, is 800 where the other paddle is? Is 800 somewhere like away from the edge? Is it past the edge? What is that number? This makes it really explicit. We'll have the exact same functionality where it bounces off the side, but it's a little more versatile now. It only bounces off one side though, it's getting bouncing off the other. And if the right side is canvas width, what's the left side? Remember that the ball's x value, when we draw that rectangle, is a distance from the left. So we want to know if it goes less than 0. Because 0 being the left side, if it goes less than that, then it is negative pixels from the left, meaning it's off the screen. And we should now have this ball bounce back and forth indefinitely. Pretty steady, pretty handy. Now notice too that right here, I still kept the same ball speed x equals negative ball speed x. Right? Don't we want to flip it to positive? And the thing to remember about what we're doing here is when we put a negative in front of something, we're really multiplying -1 times it. So if it was already -5 and we stick the -5 in front of it, then it's become positive. The way to look at this is that, okay, we have a negative and then we have ball speed x. And what I'm typing over here isn't, of course, like, don't type this. This isn't program code. This is just showing what the numbers are doing. Instead here we had ball speed x, and if ball speed x was 5, as it was earlier, it becomes -5. But if it was already -5, then we're now taking the negative of the negative, which is turning it into the positive, which is what we want. So all this is really accomplishing, no matter what direction it was going, is flipping the horizontal direction of that shot. Let's also separate out this draw code, because right now it's already kind of a headache. And what'll be nice is, what if instead of having to have 2 lines for every time we draw a shape, we have a single one that we can call to draw the rectangle. And so the way we're going to do is we're going to make a function that accepts some parameters. And here's what I mean by that. Function, color rect for color rectangle. And here I will say left x, top y, width, height, and draw color. You can call it anything, but that'll do. And what I want to do is I'm going to copy those lines and draw everything. I'm going to replace the word black here with the draw color parameter. That's the 5th one I put here. I'm going to pass in this left x, top y, width, and height values into fill rect. And what this kind of thing does for us is it gives us a template where anywhere I call color rect, oops, got this parenthesis down here, I don't need that. Sorry about that. Just a function we just defined right there. I give it the same, remember the first 2 coordinates were already left and top, x and y, followed by the width and height of the rectangle. Except now our version accepts a 5th argument, which will be the color of it, black. And this allows us to compress each of these functions into a single line. Work easier to replace the rect. But you see how it's taking the exact same sequence of numbers, 1, 2, 3, 4, and 5, mapping those onto these labels, 1, 2, 3, 4, and 5, for color rect, and then basically just filling those in. It's taking that value, filling it in down here. And otherwise we can replace the rectangle functions with those. This compresses down the code for our draw considerably. Now there's no performance benefit to doing this. In fact, it's a very, very infinitesimally, slightly more computationally expensive to do this, but like trivial. Don't worry about that amount. But this will do the same thing our program already did, but this gives it one line per shape being drawn. Let's go and save it and test it. No new errors, same behavior we already had. And let's also go ahead and label these. By label them, I mean let's just at least put some comments by them. Comments are where we can put slashes in a code and be like, next line blanks out the screen with black. And anything after a slash on the same line will be ignored by the computer. It's still visible if someone has a view source on their page, so I don't see anything too rotten in there. This is left player paddle. I'm just describing on each line, next line draws a ball. And I put some spacing in there. And this is a good way to leave notes to yourself. So if you come back to the code later and you're trying to remember, like, why was I drawing a white rectangle there? Which one was that? What is this for? You can annotate your code in this way for either other programmers or just for yourself in the future after you forget. And those have no impact on what the game does. And now, so we're drawing the ball here, and we'd like to make it a circle instead of a rect. Well, instead of calling the rect function, let's say canvas, text, fill style. Let's keep it red for now so we can make sure we're looking at the same shape. Canvas context, begin path. That begin path is going to let us define a shape and then fill in. Canvas context arc. There is no circle function in HTML5 JavaScript, it's an arc. We're going to draw it a ball X, and let's say 100, 10, 0, math, pi, times 2, true, and there's still a line left to make a circle happen. I'll explain in a second what's going on here because, right, it's pretty awful looking. Oh, math, pi's got to be capital, okay. So now we have this ball that's bouncing. Let's walk through what this is doing down here. Fill style, you know what that is. You recognize that from the rectangle code. Begin path is important because the way that we're going to fill this in is by calling fill at the end. There's no arc fill in the same way there's a rect fill. An arc is really meant for drawing like a sort of a filled in chord of a circle in which it accepts a few different arguments. The first two are the X and the Y position, just like we had for the corner of the rectangle, except here instead of being the corner of the rectangle, it's the center of that circle. We then have the radius of the circle, is the third argument. So here by saying it's 10 pixels, really the circle is going to be 20 pixels wide and 20 pixels tall. And the next two are the angles and radians around the circle that we want to make for our section of sort of like pizza, if you will. And if you've never seen radians before, this can look kind of confusing. We're going to bury this into a function to draw our circles for, so we don't have to worry about it in the future. But the way this works is that instead of dividing a circle into 360 units as degrees, which we're used to like 90 degrees is the right angle, radians instead asks how many times can I take the radius of a circle and lay it along the outside of it. And it turns out that 2 times pi is the number of times the radius fits around the circumference, which of course is also how you get like the circumference formula for a circle. If you've never seen radians, don't sweat it too much, except to say math pi is half of a circle. So if I save this, there's only the top half of the circle. I'm going to increase its size considerably so it's easier to see to 100. Here you can see we have 100 radius circle, half drawn. And now this is only pi instead of pi times 2. Or we could say like pi divided by 2. We'll get a weirdly busted 3/4 shape. Notice that it's not drawing like slices of pizza, it's drawing like the full arc and then connecting at the end. This right here, this true or false, has to do with whether it's going clockwise or counterclockwise from that angle. If I change it to false, now we see the other section of the 90-degree corner instead of the 270-degree around minus that corner. Or if we just did half of a circle, false would draw the bottom half of the circle, true would draw the top half. Now, I'm kind of showing you all this because I want those parameters to be demystified. I also want you to be comfortable just filling in those kind of numbers and just playing with it and just seeing what comes out of it. But we don't actually have to think too much about that because we're going to answer that question once. We know that math works out for 0 to math pi times 2. Math pi is just a built-in constant for 3.1415, yada yada. Why does a circle with 100 radius, drawn at a vertical position of 100, skim along the top? Remember, the radius is a distance from the center of the circle, and so this ensures that we're surfing that edge. If the numbers are the same, if we make them both 50, it'll rub along the edge at half the size. That's something to think about. But let's make the ball 10 tall. We have a ball. Let's also make it white. While we're at it, no, we want to eventually make the ball white anyhow. And there we go. We have a circle. Now, if we look at this code later, it's not going to be clear that it needs to get grouped together. It's not going to be obvious what it's doing or why. Just like we wrapped up the rectangle function into its own separate helper function is what I call these things. It's a pretty common term for them. Let's do a similar thing for the circle to hide this ugliness of how a circle gets drawn. Function, color circle. Because, for example, these extra parameters here about these two, in fact, all three of these, whether or not to go clockwise or counterclockwise, which angles to draw the circle between, we always want that same answer of what we want as a circle. All we really care about is the horizontal center position, the vertical center position, and the radius. Those three numbers. So that's the only ones we're going to ask for. We're going to ask for, let's say, center X, center Y, radius. We're not going to ask for the other ones because I'm going to cut this code. We will ask for the color, though, just like we did for the rectangle. And I'm going to replace ball X here with center X, which just gets its labels. Put some long parentheses here. Center Y would be the second number there. Place it 50. And these are going to be called arguments or parameters. Radius is the next one I want to get my hands on. We can call these anything we want. So even though these, once again, as always, these labels, even though they are meaningful to us as human programmers looking at words like radius and center X and center Y, the computer actually doesn't really care where we stick those as long as they are numbers. And then draw color, I'll stick in here in place of where it defines white. Now, for drawing the ball, I can just have a single line that says at ball X, position maybe 150Y, make a white circle. It didn't give it a radius. Radius of 10. What's nice is that now that we've figured out here's how to draw a circle, we don't ever have to look inside this function again. We don't have to worry about it. We also didn't have any reason to replace this 0 math pi times 2 or true with parameters because we don't want to change those when we draw a circle. We always know what those are going to be when we draw a circle. So we've made a helper function now for drawing a circle as well. Makes that a little bit cleaner and easier to deal with. Let's go ahead and get this ball to now bounce vertically as well. We're going to do it in the next video. Okay, so here we have our ball bouncing now horizontally. We have our separate circle draw function. We have our separate rectangle draw function further down below. What we'd like to do now is get that ball that's already bouncing side to side to also move and bounce vertically. What we can do is really just follow the pattern we've already laid out for how to do it for the x-axis, right? We know that we're going to need an x and a y position and speed. Okay, let's say the ball y, let's start at the same 50. Ball speed y, let's give it a little lower speed vertically, maybe 4. Not too terribly important. So this will go 10 pixels per frame over and 4 pixels per frame down. Remember that positive y is going downward in computer graphics spaces typically. Now for our movement code, we're going to clone what we've got for x and paste it right into the middle, which is going to make it easier to change these out for y's. Ball y. So we're going to change the y position each frame by some amount. we're going to check and see whether or not that vertical position has gone outside of the top, which is less than 0, or the bottom, which is greater than height rather than width. And if so, then we're going to flip the vertical speed. Speed for the y-axis rather than the x-axis. And again, it's really just following the exact same pattern that we had for the x-axis. We're going to do it for that one too. And now the last and obviously important thing to be doing too is to make sure that where you draw the ball, we no longer have this hard-coded 150 number. Replace that with ball y, so that as the number gets changed in code, just like the x-coordinate does, it will be reflected in the position of the circle being drawn. And with those things updated, I'm going to save that, zoom back out, refresh the browser. Syntax error, unexpected token on line 34. This will actually be good for you to see me debugging this. Let's see here, back on. There we go. I click on that in my browser. Aha! And it's showing me right here where the error is. Pretty convenient. So let's go down to right there in our source. I'm gonna not edit this out because I want you to see that once again I make errors programming too, and it is just a normal, healthy, perfectly fine part of programming. I've added those parentheses back in, saved it, refreshed. Sure enough, there we go. And now we're in good shape. We've now got a ball that bounces on both axes. Moves up and down, moves side to side, bounces off the walls. We're already getting somewhere, right? I mean, how much more is there to add for gameplay to work? We need to be able to detect when it touches the wall, if it's where the paddle is or not. We need to be able to reset, want to draw the net, want to put up some scores, get a paddle on the right side. But like, the most important part of this game, the moving thing in the center, now works. Pretty cool. Alright, so we've now got the ball bouncing on its other axis. And next up, we're going to get the player's paddle to move based on where the computer mouse is. To do so, we have to look at where we're drawing that player's paddle. Currently, the Y position is hard-coded as 210. And we want to make that a variable so we can change it when the mouse moves. Just like we have a position for the ball, let's create a separate one called, I'm going to call it paddle 1Y, in anticipation of calling the other player's paddle 2Y. Doesn't terribly matter where we set it to, but let's say 250 as we know it's kind of like a reasonable distance down the screen. That's kind of our current position, if I'm not mistaken. Let's also simplify this code by saying paddle height. And I'm gonna change it up a little bit. Paddle height equals 100. So a const as opposed to a var means constant instead of variable, which just means that this number can't be changed while the game is taking place. It'll start 100, it'll stay 100. This allows us to base other decisions in our code on that, such as what's centered for the mouse or whatnot. Now you don't have to do this. You could make a var, you could make this all lowercase and camel case, just like we do our other variables. I'm showing this here as an example of something where if we can assume that this is a constant throughout our game, then there's certain things we can do with it differently as we begin to do programming for math and spacing and positioning around the area that the player can see. You'll see also I've labeled it in all capitals and an underscore. It comes from cpound defines. But if you have a variable which is never going to change, it's nice to be able to label it in a different way that you then don't get mixed up into thinking you can set it later or change its value because you want to designate somehow it's a constant, treat it and handle it differently in your code, never assign values to it. So even though it's a const, I could call this paddle height and the code would work the same. I'm choosing though, matter of personal convention and like I say old-fashioned convention, to put it in all capitals with an underscore instead of a space or an underscore instead of camel casing, and that will let me use its height in that way. Now we're going to need to add a new function for our mouse. The way that's going to look is pretty nasty, pretty gnarly, but bear with me. We have a function, calculate mouse position, EVT, var rect equals canvas dot get bounding client rect var root equals document element semicolon var mouse x equals evt client x. As always, I'll explain this in a second after I've got it out on the screen for you to look at. Left minus root dot scroll left. Y's line will look very similar. Client y rect top. scroll top, and in that case then we can return a pair of values x, mouse x, y, mouse x, mouse y. So this falls in the category of the kind of code that we're normally not writing because it's using a little bit of special JavaScript chicanery. But all it's doing, it's really not as bad as it looks. We're going to have an event that fires every time the mouse moves. So the program's going to call a function every time the mouse moves. And that event is going to hand it the mouse coordinates it received as part of this EBT or event data. We're then getting the canvas's bounding client rectangle, which is the area that on our browser is the black rectangle we've been able to draw our game within. We're also getting a handle on the document, which is the HTML page, just like we got the game canvas off the document. And that's what this next math is doing for mouse X and mouse Y. It's taking the position it's getting for the mouse X and mouse Y, which are actually have nothing to do with our position in the canvas. Let me zoom out and show you what I'm talking about. If I just got the X and the Y value straight off of that event, it doesn't care where on the page this black rectangle is. It also doesn't care if, let's say, I scroll down to get to this game on a web page, it doesn't really care that I've scrolled. It'll always give me the same values. And so what we're doing is we're accounting for where on the page from the side or from the top is this canvas element and how far have we scrolled in the browser. And by subtracting those out, we're getting the X and the Y coordinate of the mouse within the playable space. So that this will be 0, 0, and this will be 800 by 600, regardless of how much we had to scroll to get here, and regardless of where the canvas is located on the page. Now lastly, it's returning 2 bits of information at once. Most of our return functions we're going to talk about or show or write ourselves later are going to be returning one variable at a time, because that's what most programming languages can do. There's some exceptions, Python among them, that return a pair of variables together, and this is basically just keeping our mouse code compact. It's keeping the X and the Y together. We've written that function, but unless that function is called somewhere, it doesn't happen. Here in window onload, we're going to write canvas.addEventListener. And here I'm going to say mouse move, comma, function EVT. And let's say var mouse pause equals calculate mouse pause EVT. That's the new function we just wrote. And then I'm going to say paddle1y equals mouse pause dot y. We'll get the y off of it that we returned. The way we handle input in JavaScript, and actually a lot of languages, ActionScript 3, so on, is you added what's called an event listener. That means that there's certain strings you can put here about mouse click, mouse down, key press, and so on, that you can then call a function whenever it's pressed. I'm then defining one inline right here. It's just a simple inline place, just like we did for set interval, with move and draw everything. And all that function is doing is it's getting the EVT with the mouse's information, passing that in to calculate mouse position. That is then returning for us the X and the Y position of the coordinate based on, again, like the scroll and the position of the canvas on the page. And then it's getting the Y value of that and updating paddle1y to that number. Now the last thing I want to show before we even look in the browser is you have to remember, every time we add these new numbers, you have to actually use it somewhere for that number to matter, or you're just changing a number in memory. You're just changing a value stored under some label. So I'm going to replace that as the Y value for the player 1 paddle, right here, where it draws the white color rect on the left side. And if I scroll up and look at it one last time, I'm going to save it, Control S or File Save. I also see my some text here is bumping us over. Let's just get rid of that text. What do you say? About time we got rid of it. Some text here. There we go. And I'll zoom back out to look at the browser. And sure enough, the mouse moves the paddle. Now there's a little bit of a catch in that if I move my mouse real close to the cursor, and let's actually zoom in further, you'll see that it's actually dragging the top of the paddle and not the center of it. Right? Which we probably want the paddle to stay centered on where the mouse is. Well, let's think about how we do that. Okay, if our paddle height is 100, what we're getting is the mouse Y coordinate. We want the paddle to have the same amount of height above the mouse as below it, or half of its height. Instead of setting it to exactly where the mouse's vertical position is, let's subtract paddle height divided by 2, or half the paddle's height. Remember that paddle height is being drawn as 100. In fact, let's make sure we're using that too, because I think we might not be. For the height of the player's rectangle paddle, let's put in this paddle height, which we define up above to be 100 anyway. And now this will subtract half the height of it from the position of the mouse as the top vertical position for the paddles. You'll see it's holding the center of the paddle now. And what's cool about using that divided by 2 and that filling in that constant in both places is that if I come back later and I decide I want to retune this game, let's say I find it's too hard, I want to make the paddle bigger, I can make this 250, refresh, now I have a huge paddle and it still says centered. Let's say I'm finding the game's way too easy and want a smaller paddle to challenge the player. Not a problem. I can make this 10, save it, refresh, and it's so tiny, but it's still, you can see it's still saying centered where the mouse point is, which is exactly what we want. As long as my mouse is inside the canvas. When I leave the canvas, it loses it. Let's put this back to a reasonable size of 100. But there we go. We have a player-controlled paddle. Now, it doesn't matter if the ball passes it, but we're getting somewhere, right? We have player control. We're accepting live input into the game. Pretty cool stuff. Let's get it so when the paddle misses the ball on the left side of the ball will reset. Now let's make a function that resets the ball. What does it mean to reset the ball? Well, let's say it centers it on the screen. Function, ball reset. We're going to take ball x, we're going to equal canvas width divided by 2. That'll give us the center horizontally. And ball y will equal canvas height, which will give us the vertical center. Now where to call it. Before we worry about getting it to connect with the paddle or not, let's just get it so anytime it touches the left wall, it resets. That'll be a reasonable test. And where does the ball touch the left side? You know, the horizontal position is the side we want, and when it goes left of 0, the left edge, that's what we're after. So, in here, let us, instead of flipping the ball speed, this comment mark, which earlier we used to add notes to the code in our draw code, remember these, because the code ignores anything after this comment, you can also use it to temporarily disable the line. So that's what I'm using it for here. I'm going to paste in a call to ball reset, so if the ball goes off the left side of the screen, it will run the code in the scope between the open and closed braces for ball reset. So right there, it's going to call that and center the ball. Hopefully, it's the ball, right? Currently, it doesn't matter if it touches the paddle or not. Oh. Yeah, there we go. Now it's getting kind of stuck there because, you know, it's never changing direction. Speaking of this directional change, it'd be kind of nice if, you know, the player couldn't just get wailed on like this. So I'm going to cut that ball flip direction, paste it into part of ball reset. So as part of the ball resetting, it'll also flip its direction. Let's see if that works out. Now it should no longer just hammer the left side if you miss. It should then alternate direction. There we go. Goes to the right. Confirms the other walls still behave as expected. And again, if it goes to the, it'll go right through the paddle right now. We're not checking that yet. But now let's do that. Okay, so where it hits this side, we want to know if it's where the paddle is as it crosses that side. Okay, well, what's the paddle's vertical position? Paddle on Y. So let's think through this. We've got if we want to know, is it below the top of the paddle? And the top of the paddle is paddle if it all Y, so if its vertical position is below paddle 1Y, the top of the paddle, then it's at least it's potentially where the paddle is. It also has to be above the bottom of the paddle. And we can use double ampersands here, which refers to and also. So if it's below the top of the paddle and also it is above the bottom of the paddle. Now what's the bottom of the paddle? Well, the paddle's top is there and its height is paddle height. So we can actually write the comparison this way. Let me real quick fill this in. All speed x equals negative all speed x. So if the ball is below the top of the paddle and the ball is above the bottom of the paddle, or its top plus its height, which is according to the bottom, as it is already crossing the left side, in that case, it will flip the ball's horizontal speed because it's going to bounce off that paddle. Otherwise, and that's what this else is for, the else that comes after the if that condition did not prove true, then we must be where the ball must be where the paddle isn't, in which case we should call our ball reset function. Let's save that, Control S your file, say, okay, can I reflect the ball? Reflected. And I missed the ball. Looks like it. Now, whenever you're doing this, it's good to kind of try to test near your edges. There we go, looks like I was kind of right near one edge. See if you can miss just off of either edge. That should miss, that's good. See if you can hit it with either edge, let's just miss just by the bottom. There we go. And then try to hit it with the top. That's going to be a good way to confirm that your math is working out right in terms of your expectations of where the center of the paddle is, and where the ball is, and where the paddle is. And of course, like right now, it's ignoring the paddle's thickness, but for a quick prototype, for just getting some things working, this is totally fine. Later on, we can focus on how to deal with either paddle thickness, or distance from the edge, or other kind of nice polish, but this works. Alright, now that we have the left side able to block the ball and let the ball pass, we have a little bit of gameplay already. Let's now build the right side paddle. Well, so what are we going to need? Let's make a paddle 2y. Do we need another paddle height for the other one? A paddle 2 height? I don't think so. We'll use the same number for both. They should be the same height. It's fair. So here's paddle 2y, starts at 250. Here's where we draw the player paddle. I'm going to copy that, and let's say the right computer paddle. Remembering that what's in the comments means nothing to the computer. It doesn't care. It's just for us to remember as programmers what we're doing and where. I'm going to make that vertical position 2y, so it's a different variable. It won't change when I adjust the mouse to move the left side. And its horizontal position, though, should no longer be 0 because that's the left side. Right, if I keep this as is, refresh the browser, you can see there in the middle, there's like a permanent paddle there. And that's the new one that we're drawing. I could draw that in 60. Refresh. Now it's over here. That's our second paddle. How far across the screen do we want to put it to make it up against the right edge? Well, okay, we know our paddle is 10 pixels thick, right? And we know our canvas is 800 pixels wide. So we could go in and just type in its horizontal position. Should be about 790. 800 minus 10. Again, it's 10 thick from the front to back of the paddle. Our screen is 800 pixels wide, or our canvas area is rather. And so if I do that and refresh, you'll see there it is on the right side. But here's once again where it's kind of a nice place where if we're comfortable with using it, it'd be a perfect situation to use the canvas width minus 10. I see my code is wrapping on us. Okay, so this is a nice place for us to use this canvas width minus 10, because doing so is going to make it more readable. That what we want is actually 10 pixels from the right side. It just makes more logical sense than looking at 790 and trying to remember why 790. What does that number mean? Now the other thing to look out for, though, is that now in 3 different places. Here, for the thickness of the left player's paddle. Here, for the thickness of the right player's paddle. And here, for the use of the number to mean how far the paddle should be from the right side. Those numbers need to stay in sync with one another. They need to be staying the same number. So if we change one, all 3 of them should probably change. And that's another good reason to be setting up a constant or a variable. So that not only will make it more readable of what that 10 is in the code, let's call this thickness, set that to 10 up here. This will make the code easier to read because instead of seeing 10s floating around, we'll see that, okay, that label is for paddle thickness. And if I want to come up and change that number, I can change it right here and it'll fix it everywhere that needs that number. So I'm going to scroll down here to right side paddle. So there was a case of it. By the way, when it breaks line like this, it's totally harmless. Though in fact, because it's so harmless, we can manually break line to be in control of how our code lines up. I'm just going to kind of indent here. How do I? That 10 is going to also be a thickness. There we go. So we're able to follow kind of where we made those changes. We made this constant of set to 10, so we can use it in place of the 10s in all 3 locations: the thickness of the left player paddle, thickness of the right player paddle, and how far the right player paddle gets drawn from the wall. And all that work, if I got it right, will look exactly the same in the game. But if I want to go back and change this and make this number 5, let's say I find those paddles too thick looking, I'll save it as 5, refresh. I still wind up with both paddles in sync for the right thickness, and the right one still being drawn flush up against the right edge. Let's put that back to 10 though. I think that was probably a more reasonable number. Now, before we worry about getting the ball to pass the right side, right now it's kind of not easy to test because the right side doesn't move at all. And if we even wrote the AI, the artificial intelligence, to control the right side for us, it'd be kind of frustrating to tell, is it passing when we think it is? So temporarily, while we work on getting the ball to cross the right side, let's switch our mouse control from controlling the left paddle to the right paddle. Go down to where our mouse input. Here we're adding our, every time we move the mouse, calls the event, calculates the mouse position, and sets that to the paddle 1y variable. All we're going to do is change that to 2y, since we already set up that separate paddle 2y variable earlier. Did it right up here, defaulted to 250, and because we already inserted it for where we want to draw the right computer paddle as being its position right here in code, here on the right side of that line right there. Now, with just that one switch of which variable is being overwritten by the mouse position minus half the paddle height, I'm now in control of that right paddle. This will make it a lot easier to test and see if the ball is missing or hitting, which, as you can see, it's clearly right now we're not doing that yet at all. So let's go ahead and take care of that. Let's go to, it's going to look a lot like when the ball left the left side, except it's going to be for when the ball is leaving the right side. So here's the code we did for when it passes the left side. Here's how it looks when it passes the right wall. I'm in fact going to copy and paste for now the code that worked for the left side because we already debugged it, and let's look at how is it going to be different in the case for the right wall. Well, the most obvious thing, of course, right, is that we no longer are interested in its position relative to paddle 1. Paddle 1 is the other side of the screen. Here, we want to see where it is in relation to paddle 2. Is it below the top of paddle 2? And also, that's the double ampersand, is it also above the bottom of paddle 2? It was top paddle 2 plus paddle height. If so, reflect it horizontally. Otherwise, reset the ball. And what's great is because we already thought through that logic once, we just identify what are the differences and what we need next. And okay, I can reflect the ball right there. Next time I'm just going to miss it, make a point of it, stay out of its way, and it reset. Like I say, once again, let's get the test. Like, okay, can I hit it near the edge? That seems to check out. Can I hit it near the other edge? Sweet. And then I'm going to have it miss me near each edge. Miss me below. Oop, kind of got a little too close. Let me zoom in on that a little further. Yeah, so I can miss myself on either side. Now that we have the right side working for the ball to drain, let's switch that back to player 1 control of the left paddle. And now we're in business to get the right side playing automatically, which we'll do that in the next video. Alright, welcome back. At this point we have a paddle that can reflect the ball. We have a ball that will reset if it misses either side. And we want to bring that right paddle to life. Now that we only control one paddle at a time, let's give it a way to defend itself. Let's start a little bit of logic for how to update the number, right? Because we have paddle 2y representing the position of that paddle. At the top of move everything, let's make a function called computer movement. Before it, let's set it up and make one called computer movement. And we don't have to make a function for this, it's just going to be calling this block of code from there, so that it's going to be a little bit easier to separate out what code is for that as opposed to other purposes. And all we need to think in terms of is the paddle for the other player above the ball? If so, move it down a little. And paddle 2y plus, let's say 6. I don't know. We'll go back and we'll experiment. Otherwise, if it's not above the ball, it must be below the ball. So let's have it move up 6. So a quick reminder on what's going on here. It's taking the value that was currently stored there, let's say 250, and then adding 6 to it, so it becomes 256. Setting it equal, so overriding, storing into the label going forward. So if it was 250, it becomes 256. On the next cycle through, it could become 262 and so on. Or the other direction, we'll see subtracting from it. But these operations are so common in programming where you want to add or subtract it to a number. We did the same thing down here for the ball speed, right? That it's got this unfortunate side effect of like, well, what if you accidentally made a copy and paste error and this letter, this symbol wasn't the same as that? What if you accidentally like had a different variable here? So there's a different notation that compacts this, in which I can say plus equals 6 will mean the same as what it had there, or minus equals 6 will mean the same as what it had there. I'm going to show you the format down here too, and then I'm going to walk you through it. So instead of saying ball x equals ball x plus ball speed x, I can say ball x plus equals ball speed x and ball y plus equals ball speed y. We have one less point of potential error there for a typo to happen. And then additionally, it's just more compact. It's just, a little quicker, rolls off the tongue easier. And what it means is add 6 to the value and then store it back into it. That's why the equal sign is essential, right? Because if you just wrote, this variable plus 6, that's the same as having typed on that line. Okay, so that variable, let's say it has 250 plus 6. That's the same as having typed 256 with a semicolon after it. You're not telling the computer to do anything with that number. The equal sign is with telling it, okay, once you calculate that addition or that subtraction, save it back into the variable. That's why the equal sign is also there. You can also do this with multiplication or division. So, okay, so we've got this thing which should check if the paddle's above the ball, it'll go down, and if it's below the ball, it'll go up. Let's see. Saved it, refresh, and hey, look, it's doing a crummy job of playing. It's jittery, it's awful. Something else to look out for is that it is in fact lining up the top corner of the paddle with the ball instead of the center, which remember, it's just like we did for the player's mouse coordinate here to map to the center of the paddle. Instead of comparing the top of the paddle, what we really want to compare is the center of the paddle. Var paddle to y center. Might as well capitalize that C for consistency. Consistency, but tish equals paddle to y plus paddle height divided by 2. Remember, so since this value is the top of the paddle, this will add half the height and give me the center point. Because what we really want to know isn't where is the top of the paddle relative to the ball, but where is the center of the paddle relative to the ball, and this is what's going to give me an answer to that question. So I save that. We should see the paddle now keeping a much better lock on being roughly centered. Now there's another problem with this though, and you see it's very, very shaky and jerky. Right? And what's happening is it's moving a full 6 units every time, even if it doesn't need to. So it's overstepping, understepping, going back and forth with the ball. And we can kind of alleviate that a little bit if we say, okay, once you're close enough, stop moving any closer. Right? So instead of saying like if it's above it, if it's above, I don't know, 35 pixels of it, ish. And that's just the side, our paddle's like 100 tall, and it's kind of a reasonable chunk. We can make that a percentage of paddle height, but we're just trying to get something working. And instead of having an else which says, well, if it's not going down, then shake it up, we'll have another if condition there too. Have an if-else chain. If it's within a 70 pixel sort of, you can think of as band where the center of the paddle is, it'll sit still. And that should give us much more reasonable. It's still a little bit jerky as it tries to catch up to the ball, but you can see it's not quite as bad. It's not doing the shaking back and forth as it was doing a moment ago. First, let's just put some text on the display. I'm going to go into draw everything. Let's draw the scores last. You never want scores and user interface information to be overlapped by stuff from your game, and it looks kind of weird. Canvas context dot fill text. I'm going to say score stuff. Doesn't matter. 100, 100. And it's going to display this text with the last fill color that we've set. Let me zoom in on that. It's going to display this text at position horizontal X, vertical 100. So X and Y, 100, 100. 100 pixels from the side, 100 pixels from the top. And fill text is going to inherit whatever fill color we've been using, which in this case has been white for basically everything. There we see the word score stuff. Now all we have to do is hook that up to a score variable. Let's add one for player, how do you want to call this? Player 1 score equals 0. Player 2 score equals 0. Each player has a score, which is going to start out at 0. Let's go to where the ball resets, where we call reset. So if it passes off the left side of the screen, then we want to give, if it gets past the paddle on this side, I know it's the part that's get past because it's resetting the ball. If it gets past the left side, then we give player 2 a point. And remember, we can use a shorthand here of saying plus equals 1 instead of saying equals player 2 score plus 1. There's a shorter form, it just says plus equals. And we'll do the same thing down here. For if the ball escapes off the right side without being blocked, then we increase the player 1 score by 1. And here's another shortcut. So plus 1 and minus 1 are so common that you don't actually have to go all the way of saying plus equals 1. You can just say plus plus, and that adds 1 to something. Or you can do minus minus, and it subtracts 1 from something. Because there's so often in code when we want to count something or increase something just 1 at a time. It's a little shortcut to give us. It does exactly the same thing. It's equally valid to say plus equals 1. But let's go and use plus plus to be good practice to see how that works. So it's increasing those scores. And now, instead of displaying the word score stuff, let's display player 1's score on the left side of the screen. And let's display player 2's score, canvas.width minus 100, right, will give us the same position from the right side, except we'll make that player 2 score. Save, refresh. You see now we have a 0 in each side. It's going to be tough to beat that player, but I'll dodge the ball. And you see he got a point. Now I got a point. He got a point. She did. And the scoring seems to work. When I block it, no scores change. So there we have scoring. Our core gameplay is already in place. All that's left is drawing the net and a little bit of ball control, because right now the game's kind of lame. And ball control is really important. So I'm going to walk you through that in this next video. Okay, so we're back, and as you can see here, I've left it running for a little while, and sure enough, the score is currently 440 to 881. Needless to say, the AI is doing an okay job, but it's a reasonable way to test its performance over time versus sitting still. Also, this is a reminder to us that in addition to that net and having the paddle control the ball, in terms of how it's hit, and I'll walk you through that just next, this is a reminder too, we also need a win condition. We need a maximum number of points to earn, at which point we'll end the match and we'll show who's the winner and that kind of thing. But first off, let's get ball control going. And what I mean by that is right now when you watch the game, you'll see that every time the ball bounces off a paddle, it's just reflecting it. It's just exactly as if the wall was there, and if the ball's out of the way, then it's like there's no wall there. This has a few bad side effects though. The first of which is that it means that you as a player, or the computer player, have no influence on the path of the ball. That means that technically, as soon as you've touched the ball, you can actually extrapolate just looking at the lines where it's going to be and immediately start moving there. Now, secondly, you have no reason to take risks. You have no reason to try to hit it with the edge of your paddle. Right now, every time you get right in front of where it looks like the ball's going, you put your paddle right in the center of it and play it safe so you have maximum margin for error on both sides. It would be great is if you have a way to incentivize the players, a simple, clear way to incentivize the players to try to hit the ball with the edge of their paddles, which is, of course, going to increase the chances they're going to be a little overconfident and miss. The way all that happens has to do with the angle that the ball takes after it bounces off the paddle. So let's look at where we're reflecting the ball when it bounces off the left paddle. So it's right here in the code. And you'll see all we're doing right now is we're reflecting the horizontal speed, and we're going to keep that portion, but we also wanted to have it affect the vertical speed of the ball. Ball speed Y. And the relationship between ball speed Y and the part of the paddle it hits, that again this has been classically determined, it's been around for 35 some odd years, is when the ball hits the middle of the paddle, it'll go back in a straight line. That'll penalize players who try to play it safe by hitting it with the middle. The closer you get it to either edge of the paddle, the steeper an angle and the faster the ball is going to be. So, you know, the further it gets, say if you hit it real close to the one end, it's going to go up and real steep near the top. If you hit it real close to the other end, it's going to real steep and down below. Hit it in the middle, it's going to go to a straight line and kind of everywhere in between. And there's kind of an easy way to think through this. We can do this with math instead of having to worry about segmenting the paddle into chunks or parts. Because we know we want it to go at a 0 vertical if it's at the center of the paddle, let's begin by subtracting the center of our paddle from the ball's current position. So I've got, let's see, var delta y. Deltas, don't get intimidated by the idea of delta, it's just a difference, equals the ball's vertical position minus paddle 1y, since that's the paddle that it is being hit by. So that, but then once again, whenever we want that center of that paddle we want to add half the height to it. So this is just going to give us a plus or minus value for how far below or above the center of the paddle is. And if it's right lined up with the center, it's going to be 0. And we could actually directly set our ball speed y off of that, ball speed y. But the downside of doing so is that that number could be pretty big, right? Our paddle is 100 pixels tall. This could be up to 50, and a vertical ball speed of 50 is going to be pretty out of control. So let's instead dampen it just a little bit. Let's make it about a third of that range, which will give it a more reasonable vertical speed. And we can tune this number, play with it. Of course, I played a little bit ahead of time to guess that 0.35 works nicely there. And we can go back into the game and we'll show it, but first let's hook it up for the right paddle too, so we can kind of see it from both sides. I'm going to paste it down here. Now remember that when you paste it for the other paddle, you no longer want to base your calculation on the player's vertical height, but on the computer player's vertical height. So we're going to replace paddle 1y there with paddle 2y. Saving that. So now I've reset the game, and what we should see now is that when you hit the ball near the edge of a paddle, it should get a vertical speed based on about how far you hit it from the center. And let's see if I can recreate that. So there we go. I hit it about kind of a little above the middle. It went up a little bit. If I hit it near the bottom a little bit, it'll go a little bit straighter. Now, one thing to keep in mind when trying to test this feature is it's a little hard to extend exactly what's going on, because remember that it's setting. There we go. I hit it kind of right in the middle. It's actually being based on where it crosses the line or the total edge of the screen, not necessarily. There we go, right in the center, not the front of the paddle, since we're kind of ignoring the thickness of the paddle in these calculations. But basically, you should now have control over, like, okay, well, the player's up there. I'm going to shoot it down to the opposite corner. You can see that. I can try to have some deliberate action to interact with it, or I can try to make a steeper shot. Ooh, boom. And that zigzag, of course, makes it harder to return. This incentivizes taking riskier shots with the ball and not just always playing it safe. But, you know, it's a lot more fun. This is one of those things that oftentimes when people make a clone or a remake of one of these classic games, they'll forget this feature, and it's really instrumental to what makes this game work. Because now you have some control and some say over where that ball goes. So that's our ball control. Okay, so the next thing that our game needs is a win condition. Right now the score can just keep going up and up and up. And so let's look at where and how we do that in the code. We're already storing values for player 1 and player 2 score. We just need to look and see where do those values exceed a certain amount to play to. Like, it could be 3, could be 7, could be 15 or 21, depending on the pace that you want your game to go at and how long you want sessions to be. Let's define a constant for that, just like we do for our paddle height and thickness. And that'll be good because, once again, it ensures that, like, our numbers will stay in sync for how many points both players want. It ensures our code will be easier to read because we'll be able to see, you know, is player 1 score greater than or equal to winning score is a little more clear than greater than or equal to 3 or 7 or whatever number we might just type randomly into there. So I'll say const winning score equals 3 is a good starting value. Maybe we'll decide later we want a bigger one, which, since it's right here, will be easier to tune and tweak. But 3 is going to be easier for us to test. So I've got that number now. And where would it make sense to check the logic for that? I mean, conceivably, we could check every single frame that the game is being drawn, but, you know, scoring doesn't happen that often. It's really not necessary to check it every time everything's being updated in the game. It only really happens right before the ball gets reset, or as part of the ball being reset, where that means that someone must have scored on somebody. Well, let's look at where that's happening in our code. And the first thing I'll point out, kind of maybe done deliberately for point of illustration, so I'd like you to believe, is that I'm adjusting score here after I reset the ball. Before, it didn't really matter. Like, why do one before the other? We wanted two things to happen. We wanted the ball to reset, and we wanted the score to be adjusted. But if we want to make our win condition check part of the ball reset logic, then we should add to the score before we call ball reset, so we can base the decision on whether or not to end or reset the scores in the match on whether or not one of the scores has reached enough points. Does that make sense? And here's one of these places where, again, earlier on we could think of it as just being, we need both of these things to happen, order doesn't matter, but suddenly the order matters. We have to add score before the reset to make sure that we're calculating for the most recent points. Because that's sort of this thing that might not be obvious if we look at this code later, that would break something if we change that order, let's put a small comment here. Must be before ball reset. So at least calling attention to later, that's the case. And we won't accidentally flub up and mix it up the other way. And again, that's one of the main uses of comments, to leave notes for future us, so we don't come back and mess something up, not realizing how important something was when we made a little subtle change back when we were working on it. So we've got player 1 and player 2 score being increased. We have winning score as a constant, And inside ball reset, let's just take a look at the top of that function and inspect whether player 1 score is greater than or equal to winning score, or else, these are or bars, they're much like the double ampersand and also, except kind of the opposite. Player 2 score is greater than or equal to winning score. And what I mean by they're like the and also symbol, remember these were and also. If we use the and also, this would mean that both scores would have to exceed 3 points, or meet or exceed 3 points, for this to happen. By using or bars, and those are, you see where like the backslashes are on your keyboard? Shift that key gives you these vertical bars. This means or else. And in this case, either one of these can be true for this if statement to trigger and activate its insides. So inside there, if one player or the other has earned enough points that the match is over, let's go ahead and reset both scores. We do something a little more elegant in a moment to acknowledge who won, or that someone even won at all, but this would be a good starting point. 0 both scores if either player has exceeded the winning point total. And we can see already when I go back to our program, the need for this is pretty dramatic, because while it ran in the background, our scores became 84 to 86. Alright, well let's reset that. Now that we've saved the text files, always make sure you save your source before you refresh in the browser. And let's just let the AI computer player get a few points on us and see if it works. 1 point. 2 points. Now if it worked, we should see, when he scores the third one, there we go. Both scores zeroed out right as his score, or her score, reached 3. Now, in order to test scoring on the other player, we could sit here all day trying to play the game better and better. I'm going to say that's not really a great use of your time. Instead, let's go back to the code and temporarily turn off computer movement. Remember that these comments, the 2 slash marks that we use to give ourselves notes, to tell the computer don't try to run this code, can also be used to say temporarily ignore this. It'll still be there, easy for us to switch it back on, we won't lose track of how it's typed or where it goes, but saving that change and refresh the browser, and now the computer player will sit still. Hopefully I can get these points. There we go, 2 points for me. If this third point scores, I'm going to find out if it worked, and it did. Both scores now zeroed back out. It's okay, so now we have a maximum score happening, although we're not really being very, there's not a lot of finesse here, right? It's just happening and then brutally, instantly resetting the scores. If you're not watching right when it happens, you're going to miss it altogether. So let's make sure the game acknowledges that somebody won by pausing the action until maybe we click to bring the game back into action. Oh, let's go ahead and take off that comment that was disabling the computer player from letting play. Let's have a variable. And when that variable is set to true, we'll have the game kind of in a locked title screen or between rounds mode. A var showing win screen. So far you've only seen us setting values to whole numbers, 1, 3, 14, 10, 250. You can actually set these also to true and false, which makes them very easy to signal to yourself elsewhere in the code whether or not you are currently showing the win screen, because we don't have to check like if showing win screen is equal to 1 or is greater than 0. We can just check if showing win screen. If you're coming from another programming language, you may be used to seeing things like bools or booleans as a way where you define a different type of variable in what might be an int or a float than a number. But in JavaScript, they're all var. And based on how you assign the value, JavaScript figures out for you, okay, this is going to be a true-false value. This is going to be a whole number value. And it figures it out as we go. So that's what we're going to do for our win screen. And we need to check and see where those scores get exceeded. And let's flip it to true there. And by flip it to true, I literally just mean we just tell it literally true in all lowercase. So it started off as false. It became true there. While it's true, let's skip the move everything code if we're currently showing the win screen. And by skipping it, we can use an if statement. So if it's currently true, we don't actually have to explicitly check and see if it's true. That's what this is doing. I.e., we don't have to say equals true. Then return, and return is just a way to bail out of the function prematurely. Nothing else in move everything will get a chance to even happen if this return gets hit. We can do the same thing in draw everything. So if we're on the title screen, we won't even see the paddles or anything else. Maybe we'll leave that blanking line in, that background that blacks everything out. And while we're on the title screen, let's show a message that indicates what's going on. Let's get this fill text from below. If we're on the title screen, let's just say, click to continue. Click to continue. And I see I lost my parentheses right there. Okay, so it's got 1 point on me, it's got 2 points on me. As soon as it scores at third, oh, now we're blacked out. Now the problem, we're not seeing the text. Remember that we're using fill text, which is using the previous fill color, which was set to black by color rect at our source. So we will need to fix that. We can come down here, borrow a fill style call. We could make ourselves a separate color text function if we'd like, just like we did for color rect and so on, but just to get this working, let's check and see. If I set this back to white, and 1 point scored, 2 points scored, and this should be our third point. There we go, click to continue. Now we can't yet click, but we'll hook that up next. Okay, so here we are where we have the game, so when it ends, when either team reaches enough points, it says click to continue, but there's not any way to click to continue. So what we're going to have to do is connect another event function, just like we did for when you move the mouse, to the event that happens when the mouse button goes down. So let's look at where we connected up the mouse move function in window onload. And let's connect another one to canvas.addEventListener. Although this time, instead of connecting it to the mouse move event, we're going to connect it to one called mouse down. And we'll connect to it, instead of doing an inline function like I wrote here, where I'm defining it in place, let's just make one called handle mouse click, which we're going to find elsewhere in the code. Let's scroll up here above window onload, say function handle mouse click EVT, which we don't actually need in this case, but that's standard for anything you hand an event to be able to receive it in case it wants information off of it. And if we are showing the win screen, then at that time, zero out both scores. Let's make sure we don't get a typo in our score. Player 1 score. So if we're currently showing the win screen, then we want to zero out both scores. Player 1 score, player 2 score. And then we also want to turn this back off to regain control of the game on the occasion of clicking when we're on that screen. And this is another way to hook up these functions. Just want to show some examples of how things can be done in JavaScript. We can do it inline like this if it's something like there's no reason why we'll call a function anywhere else. Or if it keeps things tidier for us, we can just call it by its name. As shown here, handle mouse click isn't a special word in the same way that say mouse down is. That's just whatever we want to call the function. When I scroll up, I can just define it right there. So again, here's our function zoomed in on it. If showing win screen has been set to true, clicking will zero out the scores and return the player back to play by clearing the win screen. Now the reason I'm clearing the scores there, let's go ahead and do kind of two birds with one stone here, is let's look at where we set that to true. We don't actually want to zero the scores at this point, because how else will we be able to easily display what the scores were when the round ended, right? Or at least to say who won. So let's not zero the scores there yet. We'll wait until the player clicks from the game end screen to go back into play to then zero out the scores. I'm going to borrow this statement here, which has a comparison of each score against winning score. And let's go back to where we're drawing this end screen, where it says nothing but click to continue. So down here in draw everything, if we're showing the win screen, then we're showing that click to continue message. Let's move that a little further down on the screen. It doesn't seem to me right like it needs to be in the top left corner like that. Let's move it, I don't know, over some, wait, how would, maybe not that much, or 800 pixels wide. I'm kind of eyeballing this stuff. Maybe 350. How far down? Let's say 5 out of 600 vertical. 5/6 of that might look okay. And now, here's why I copy and pasted those lines. I don't actually want to keep that OR bar, but I do want these general expressions because I want to post a different message based on which player earned enough points to have ended the round. One of them must, since they passed that OR bar, to have flipped show win screen in the first place. And so if player 1 finished, let's go ahead and move this color fill up here. It can be shared among these. Now, I don't need it. Well, yeah, if I indent, you're going to see it wrap, but that's fine. Let's say left player 1, And for position that, let's put that closer to the top of the screen, maybe 200 down. And I'm going to do the same deal here for player 2, where I will say write player 1. And it can be in the same position because, of course, the nature of an if-else statement is only ever going to show one of these or the other. It can't show both. Even if both of these were true, and this isn't the kind of game where you can have a draw from people winning at the same time, even if they were both true, if this first if condition passes its test, it won't even give the else a chance to evaluate. So we know these two will never overlap. So let's save it. We'll give it a second to catch up its scores. Let's just let the computer player win this time. It should say, write player 1. Click to continue. If I click, it reset. The scores are going to 0. Now let's try beating the computer, which once again, easiest way to do that, well, maybe I can look into defeating it with skill. Yeah, left player 1. By skill, I mean, just sitting there while it can't catch the ball fast enough. Click to continue. There we go. So okay, so we've got now, we can click from the end screen. It tells us which player won. Let's go ahead and add that net. It's a good, attractive thing to add to the playfield. And you wouldn't think that it really adds that much, but it helps balance things out. It's a nice little bit of visual polish to end on. So let's go back to our code. Let's look for draw everything. Circle, rect, color circle, color rect. Draw everything. Let's just make this above draw everything. Right now everything lives in one file. That's fine. We're almost done with the project, so we can just pack in just a little bit more. Let's make a function called draw net. And in draw net, we're just going to do a for loop, which I don't actually think we've used anywhere yet in this program. I equals 0. I is less than canvas height. Remember, that's going to be the vertical height of the screen, so 600. I plus equals 40. That's my cat eating in the background. Hope no one minds. And in here, all this is saying is start a variable at 0. The variable here is I. Count up to less than 600 in intervals of 40. So jumping 40 pixels at a time. It doesn't actually mean pixels here, just mean numbers. We're going to use it as pixels. And at each location, we're going to draw a color rect. Remember, we made this function to be able to draw a shape in a position. And let's say canvas.width divided by 2 minus 1 to center it. It's going to be too thick. We're going to draw it at I, its width 2, and its height 20. And my reasoning here is that, okay, I'm going to make this 2 pixels thick. That helps me see I'm balancing it here in the center where I start at the middle, move it left 1, so it'll have a pixel on either side. At I, this is the variable in the loop, so this will happen. Like I say, it starts at 0. It'll go as long as it's less than 600. It's going to jump in intervals of 40 pixels at a time. So it's going to start at 0, then 40, then 80, then 120, and so on. And at each location, it'll put the shape there, which is 2 pixels wide and 20 pixels tall. And of course, if I make it black, we're not going to see it. So let's make it white. So we should see a net just drawn every other segment going down the middle. Lastly, remember that just because we put code into a function doesn't actually mean it does anything until we call that function from somewhere else. So let's figure out where we want to put it. Do we want it to show up on the game over, game lose screen? I don't think so. So if we put it above here, it would still show up on that win screen. If we put it below here, this is the player paddle. The paddles will never get in the way of it anyway. Even if, let's say, the ball was a different color. Let's say we made the ball green. We'd want to be able to see it on top of the net, right? So it should be drawn after the net is. So this position should seem to work fine to me. I will save it. There's our net. So we have a game. We can play to 3. We have an AI which plays. It's not great, but it works. We have mouse input. We have circles being drawn. We have motion. We have bouncing. Man, what a day. Congratulations on finishing your first video game project. Hopefully the first of many. Now, you might have noticed that in the sidebar over there, you can see that this was actually just section 1 for tennis game. And what it's section 1 out of is hands-on intro to game programming. You'll find the exact same sort of approach taken for 5 other types of games in here, which include Brick Break, racing game, bitmapped graphics. We have 2-player simultaneous keyboard controls, Warrior Legend, which takes that same kind of framework, but then shows how you can remake that into a completely different experience with a warrior who walks around, collects keys, open gates. Each one of those 6 games in the first half of the book and the second half of the book are training you in, covering different sets of skills that'll then form a solid foundation from which you can go on to develop original projects